Welcome back. Now in this part we are going to study about the general equation of ellipse. So suppose that if an ellipse is at some other point or anywhere in the 2D plane, so how can we find its equation? Then we are going to study about the auxiliary circle, and we know that auxiliary circle gives us the parametric equation. So we are going to study what is the parametric equation of an ellipse. We are also going to study about the position of a point with respect to ellipse in this part. So let's start. Now let's start by finding out how can you find the equation of ellipse if it's not in its standard place, but if it's at somewhere in the 2D plane, and if it's inverted or if it's any shape. Okay, we are not going to put any restrictions, but what we are going to do is that we are going to find out equation of ellipse in any form or anywhere it's lying. Let's take this case. For example, you can see that the equation of ellipse is lying somewhere around here, and these are our coordinate axes. Now again, according to the definition, we need only two things: one fixed line and one fixed point. This is the one fixed line, that is the one of the directrix. This is the one fixed point, that is h comma k. Let the coordinate of this variable point p, which is moving, be x comma y. Now what is the basic definition? Distance from fixed point, that is SP, divided by distance from fixed line, that is PM. This PM is equal to E. That means we can say that SP is nothing but E times PM, where E is our eccentricity. Now what is SP? We know that the coordinate of S is h comma k. So SP will be root of x minus h whole square plus y minus k whole square. This is the distance formula of distance between 2 points. E times, what is PM? PM is distance of this point from this fixed line, or that is this perpendicular distance. So we are going to use the perpendicular distance formula, that is mod of, we know what is the equation of this line. The equation of this line is ax plus by plus c is equals to 0, that is the directrix. So mod of ax plus by plus c divided by square root of a square plus b square. So this is the distance formula. Now this equation is in root form, and it doesn't looks like equation of an ellipse. We can modify this equation and we can bring it into the standard form, but this is the method to find out the equation of ellipse in wherever it's lying or in whatever form it is. Now if you want to simplify, the very basic first thing that we are going to do is that we are going to whole square it so as to eliminate the mod and eliminate the roots. And then if you cross multiply this a square plus b square on this side, and if you put the value of e and simplify, you will get a general 2-degree equation. Now remember, if there is a general 2-degree equation, then it can represent many things. It can represent circle for some values, it can represent parabola for some condition, it can represent ellipse which we are looking for, and it can represent hyperbola as well. The crux to find out that what it's represent is lying in these coefficients. Remember that we have renamed the coefficient, don't confuse that these coefficient and these coefficients are same. So it lies in this coefficient. Whatever the 2-degree general equation you have, write it in this form, and if this del value, del, that means ABC plus 2FGH minus AF square minus BG square minus CH square, where A, B, C, G, F and H are the coefficients in this equation. If this del is not equal to 0, and provided that H square is less than AB, if these two conditions are satisfied, that means the 2-degree general equation represents an ellipse, or it's an equation of ellipse. So remember, whatever 2-degree equation you have, if you want to check that whether this equation represents an ellipse or not, you need to verify these two equations. So you need to find the value of del, and then you need to compare that what is the value of h squares compared to AB. Now let's take a question on this. So we need to find the eccentricity and latus rectum of this ellipse, and we need to also find its center, focus and directrix. Now this is again a 2-degree equation. Okay, now because it is written that it's an ellipse, so I'm not going to check for all those things, but you can see that if it wouldn't have been ellipse, then I would have to check whether this 2-degree equation represents an ellipse or not. But now it has been said to me that it's an ellipse, so I am not going to verify the del value and h square value. Rather, I am going to straight away move towards the solution. Now, our basic equation is this. Let's say capital X square divided by a square plus capital Y square divided by b square is equals to 1. Now, eccentricity of this ellipse is given by b square is equals to a square 1 minus e square. Latus rectum of this ellipse is given by x is equals to AE. Center of this ellipse is given by capital X is equals to 0, capital Y is equals to 0. Focus is given by x is equals to plus minus AE and y is equals to 0. That is the focus. And directrix is given by capital X is equals to plus minus A by E. So these are the equations. This is the equation of directrix. This is focus. This is center. This is equation of latus rectum. And this is the eccentricity equation. Now, we need to convert this equation into this form. If we got this form, then we know all the things, how to find out them. So let's do it. 4x square and there is 8x. We are going to make whole square here. There is no xy term and we are going to make whole square here. So if I take the x term on one side, then I can write it like this: 4 of x square minus 2x. Plus I can take similarly 9 common from y terms, y square minus 4y, and then plus 4 is equals to 0. Now I am going to make whole squares. X square minus 2x, clearly we need plus 1 here. So if I am going to add 1 here, I am going to subtract 1. So what I am going to write it 4 of, look, x minus 1 whole square, I have added 1, so I need to subtract 1. Similarly 9 of, again, which whole square this is going to be? This is going to be y minus 2 whole square. So that means I have added 4 here, so I have to subtract 4 and then plus 4 which is there in the equation. That means what I got, x minus 1 whole square 4 times plus 9 times y minus 2 whole square. How many constants I have got? This is minus 4 from here and then plus 4 will cancel out. Minus 36 from here, it will go on that side, it becomes 36. Now you can see we have easily carried out the transformation and I can see the equation now. If you divide by 36, then I will get x minus 1 whole square by 9 plus y minus 2 whole square by 4 is equals to 1. So clearly this is a square, this is b square, and my a square is greater than b square. That means these formulas are valid. If b square would have been greater than a square, then my ellipse would have changed its orientation. Its major axis then would have been the y-axis. But now because a square is greater than b square, my major axis is actually parallel to x-axis. It's not x-axis, it's parallel to x-axis. Let x minus 1 be capital X and then let y minus 2 be capital Y. So that means I have gotten this equation. Let's first find out eccentricity, because we need eccentricity to calculate other things. So what is eccentricity? B square is equals to a square 1 minus e square. That means b square 4 is equals to a square, that is 9, 1 minus e square. That means my e square value is 1 minus 4 by 9, or my e is, this becomes a 5 by 3, root 5 by 3 I must say. So this is my eccentricity value. Now I have got the eccentricity. Equation of latus rectum, x is equals to a. What is my x? Capital X is equals to a. So that means capital X is equals to a. What is a? A is 3 into e, that is root 5 by 3. But remember, this is capital X. What is x? Capital X is actually x minus 1 is equals to root 5. So my equation of latus rectum is x is equals to root 5 plus 1. This is equation of latus rectum. X is equals to y is equals to 0 is the center. That means capital X. So x minus 1 is equals to 0 and y minus 2 is equals to 0. This is my center. That means my center is 1, 2. This is my center. Lateral rectum is over. Center is over. This is focus. X is equals to plus minus a and y is equals to 0. So x, that means capital X or x minus 1 is equals to value of a is root 5. So x is equals to, and there is a plus minus sign here as well. So x is equals to 1 plus minus root 5 and y is equals to 0. That means y is y minus 2. So y is equals to 2. That means your two focuses are 1 plus root 5 comma 2 and 1 minus root 5 comma 2. Similarly, equation of directrix. Equation of directrix. How I can find equation of directrix? X is equals to plus minus a. That means capital X. So x minus 1 is equals to plus minus value of a is root 5. That means your equation of latus rectum is x is equals to 1 plus root 5 and x is equals to 1 minus root 5. So these two are equation of directrix. So in this way, you can see that to this general 2-degree equation, I have transformed it and I have found out all the possible values that you may ask me. So this is the method to solve this question. Let's move to the next concept, that is position of a point with respect to an ellipse. Now, let's say that the equation of this ellipse is given by x square by a square plus y square by b square is equals to 1. If this is the equation of ellipse, there can be three cases possible. Suppose there is a general point h comma k. This h comma k can either be inside the ellipse, can either be on the ellipse, or can either be outside the ellipse. Now in these cases, what we need to do is that we need to transform our equation a bit and we need to modify and we need to see x square by a square plus y square by b square minus 1 is equals to 0. Now, we know that if this h comma k point lies on the curve, that means it is going to satisfy this equation. So, h square by a square plus k square by b square minus 1 is equals to 0 here. That means if your point is on the curve, then it is going to satisfy this equation. If your point is outside, let's number them. This is case number 1, this is 2 and this is 3. So this is for case number 1. If your point is outside, that is case number 2, then this value h square by a square plus k square by b square minus 1 will be greater than 0. So if this point is outside, that means this value will be greater than 0. Similarly, if this point is inside, then it's very obvious, then this value will be less than 0. So depending upon where your point lies, you can put them in the equation and you can see the value or the sign of this expression. If this expression is positive, that means the point is outside. If this expression is negative or less than 0, that means the point is inside. And if this point is on the curve, that means it is going to satisfy the equation or it will give you a value 0. Now we'll move to the next concept, that is the auxiliary circle. What is an auxiliary circle? So the circle described on major axis of an ellipse as a diameter. So what we are taking major axis of ellipse as diameter, it's called the auxiliary circle. So if major axis of ellipse is diameter, that means the center of this circle is obviously 0, 0 for a general ellipse and its radius is a, because its diameter is 2a or its diameter is major axis. So major axis is diameter, that means the whole 2a is diameter, so a will be the radius. So in this manner, this is how the auxiliary circle looks like. You can see that the major axis has now become the diameter of the circle. Its equation will be obviously x square plus y square is equals to a square. Now what is the use of auxiliary circle? We all know that auxiliary circle is used to find out the parametric equation of any curve. This is the auxiliary circle. Let's say that this angle is theta. Now we know that the radius of auxiliary circle is a. So this point or this length will be a cos theta. This length will be a sin theta by resolving the component. That means this point is a cos theta, comma a sin theta. If this point is a cos theta comma a sin theta, you can clearly see that the x coordinate of this point is going to be same. So the coordinate of this point, let's say be a cos theta, because the x coordinate is same. Let's say its y coordinate be k. If we somehow can find out this value of k, then we got the parametric equation of this curve. That means for any value of theta, we can locate the point on the ellipse. So we need to find the value of k. How can we find the value of k? The very basic and easy method is that this point lies on the ellipse. So put this point on the ellipse and we are going to satisfy it. That means x square by a square plus y square by b square is equals to 1. The general equation of ellipse. Put the point and try to satisfy them. That is a square cos square theta divided by a square plus k square by b square is equals to 1. If I try to simplify it, that means k square by b square is equals to 1 minus a square cos square theta divided by a square. That means what I am going to get is k square by b square is equals to sin square theta, or k is plus minus b sin theta. Now why are we getting plus minus sign? Because for the same theta which is on the negative side, you can get one more point, which is this. You satisfied the x coordinate only and you are looking for the y coordinate with respect to it. So for this x coordinate, there can be two y coordinates. One can be this and one can be this. That is why we are getting two coordinates. But because our theta is lying in the first quadrant, so we are going to take a cos theta comma b sin theta as our parametric coordinates. So remember that if you want to assume any point, any general point on the ellipse, then a cos theta and b sin theta will do the trick. Now let's try one question on this. So the question says that consider an ellipse of x square plus 3y square is equals to 6 and a point P on it in the first quadrant. So the point P is there, which is in the first quadrant. It's at a distance of 2 units from center. So the point is at 2 units from center. We need to find the eccentric angle of that point P, which is 2 units from center. So let's try to solve it. The figure of this question will look somewhat like this. This is the point P of whose eccentric angle we need to find out. Its eccentric angle is this theta. Let's say that x1, y1 is this point P. And let's say that corresponding to this point P, there is a point Q which lies on the auxiliary circle. We know that their x coordinate is going to be same. That means x1 and x1 will be same. And let's say that its y coordinate be y2. So this is the point which we need to find out, and this is y2. Actually, the eccentric angle or tan theta will be given by y2 by x1. But we have the required information in some other form. So let's try to solve it. First of all, point P lies on the ellipse. So what I am going to write is that x1 square plus 3y1 square is equals to 6. Now point Q lies on the auxiliary circle. So what is the equation of auxiliary circle? The equation of auxiliary circle is x square plus y square is equals to 6, because a square is 6. Now point x1, y2 lies on this auxiliary circle. So x1 square plus y2 square is equals to 6. Let this be equation number 1 and let this be equation number 2. If we solve equation 1 and 2 simultaneously, I am going to get y2 square is equals to thrice of y1 square. That means y2 by y1 is actually equals to plus minus root 3. Let's say this be equation number 3. We need one more condition. The one more condition is already there. Distance of this point P, x1, y1 from origin is 2 units. That means I can clearly write x1 square plus y1 square is equals to 4. If I eliminate, let's say this be equation number 4. If I eliminate from 1 and 4 x1, I am going to get value of y1. Look how. So eliminating x1 from equation number 1 and 4, I am going to get 3y1 square minus y1 square is equals to 6 minus 4, that is 2. So 2y1 square is 2. That means y1 is actually plus minus 1. If y1 is actually plus minus 1, that means y2 is actually again minus plus or plus minus, it's either ways, it's again root 3. Now we need x1. how to get x1. This is the condition, how to get x1. Because what do we need? y2 by x1. So we put value of any x, value of any one, let's say put value of y1 or put value of y2 here. So if I put the value of y2, what I'm going to get? I'm going to put value of y1 in equation 2. So x1 square plus value of y2 is root 3. So root 3 square is 3 is equals to 6. That means x1 is also plus minus root 3. Now tan theta, that is y2 by y1, is actually plus minus root 3 divided by plus minus root 3. That is theta is either plus minus pi by 4. Because tan theta equal to plus minus 1 is plus minus pi by 4. That means there are two such eccentric angles possible. But we need eccentric angle in first quadrant. That means we are going to eliminate this negative sign and our answer is theta is equals to plus pi by 4 only. There can be one more angle possible, na? But it's not in the first quadrant. It's already written that we need it in first quadrant. So based upon first quadrant, we need only theta equals to pi by 4. You can eliminate this thing here as well, as where I have taken plus minus. You can only take plus signs because we need it in first quadrant. So you need to take care of that first quadrant thing either at the end or you can take it at the beginning as well. It's up to you. So this is it for this part. I hope you have understood the general equation. Also, the auxiliary circle and parametric equations are very easy. Remember that you need to remember them. So for example, if you need to suppose any point on an ellipse at any point, then you need to remember the parametric equations. In the next part, we are going to study about the tangents to the ellipse. Stay tuned.